Thank you and welcome to this YouTube channel where I'm going to work with you on the calculations of moles and molarity. Kindly subscribe, like the video, and comment as shown in this video here. So kindly subscribe, hit the notification bell so that you can be notified once you upload a video, just the way it has been done. You click the subscription button, then after that you like, and again subscribe, and again hit the notification bell, so whenever we upload a new video you'll be able to be notified. Thank you very much. So just the way we have said, I've said that we are going to discuss the moles and molarity. There are some concepts because moles in most of chemistry, physical chemistry, we deal with the calculations, and most of the calculations involves moles. So in our previous video, we defined what mole is, and also we define what molarity is. So you can follow me for more video. I'll be able to demystify, make it simple for you to understand this crucial topic, because it is a topic which cannot miss in any of your examination in chemistry. So welcome, and let us now begin this journey together. So there's at the end of this lesson, there are some objectives that we need to achieve. So you can see the objectives. So there are some objectives that I've identified. By the end of this presentation, you should be able to achieve them or obtain them. By the end of this presentation, the learner, which is you, should be able to, one, relate mass, molar mass, moles, and use the relationship to calculate mass, molar mass, and moles. Another one is to relate moles and molarity. We see the relationship between moles and molarity, and we use that relationship to at least do some calculations on how we can obtain moles and on how we can obtain molarity. Also, the last one is to relate now the concentration in grams per liter. We relate with the molar mass, and also we relate it with the molarity. So at the end of this lesson, you shall have known all the formulas that can be used to calculate moles, all the formulas that can be used to calculate molarity. Thank you, and let's proceed on. So now check this one. So moles can be gotten as moles can also be gotten as mass in grams all over molar mass. That is mass in grams all over the molar mass. And in our previous video, we discussed on how to calculate to get the molar mass of a compound or a substance or a molecule or an element. We'll be able to review that. Then we have the general formula that at least will help us the general formula which will help us to master this. So we have M stands for the moles. That is not the moles, but mass, I mean. This M stands for mass, the mass of a substance in grams. Also, we have N, which stand for the number of moles. Then we have Mr, which stand for the molar mass. For us to get mass is gotten by moles, the number of moles times the molar mass. Then now the number of moles, just the way we have said it here, it can now be gotten by the mass of a substance over its molecular mass. And this also molecular mass can also be gotten by mass of the substance over its number of moles. So it is just a matter of making making a subject the formula so that you will be able to calculate the subjects that maybe you are required to calculate. So let's see these examples. We have some examples, worked examples. For example, the first one, we are required to calculate the number of moles in 0.23 grams of sodium atom. Sodium atom is written like this. So that is the sodium atom. And we know that one sodium atom has got a molar mass of 23.0, or you can just say 23. So how do we calculate moles? We say that moles is gotten by molar, that is mass over molar mass. And in this case, we have mass to be 0.23 and molar mass is 23. So it will be 0.23 grams divided by 23. As shown here, you can see we have said that the molar mass is gotten by, the moles. Sorry, moles is gotten by mass in grams over molar mass. So it gotten as mass in grams over molar mass. So like in this case, the molar mass is 23 and the mass in grams, which were given here, this one here is 0.23. So 0.23 divided by 23, we get 0.01 moles, which you can write as the symbol for mole is MOL, like that. So that is the symbol for mole. So you can decide to write as 0.01 mole, like that. So you can be very much correct. Another one is this one. Calculate the moles present in 1.3 grams of dilute sulfuric acid. You can pause the video, then you try to work out that. We said that moles is gotten by mass in grams all over molar mass. And in this case, our mass is 1.23 grams. Then the molar mass of the sulfuric acid, you have to know how to write the molecule or the compound of the sulfuric acid, which is written as H2S0, or that is 4, like that, SO4. So this is the molecular formula for the dilute, or for the sulfuric acid. So how do we get its molar mass? So molar mass will add the relative atomic mass of each element making this molecule. Like hydrogen, we have been told hydrogen has atomic mass of 1, and here there are 2. So 2 times 1 is 2. Then we add to sulfur, it is only 1, and its atomic mass is 32. So then we add 32. Then we'll also have oxygen here. There are 4. So 4 times this 4 times this, it is 64. 4 times 16 is 64. So if you add all this, will give you 98. So we have the molar mass of sulfuric acid to be 98. So the moles now will be a mole, that is mass, that is 1.23. Then you divide by 93. As shown here, you can check. So we have said moles is given by mass in grams over molar mass. Then we have the molar mass of sulfuric acid. Yes, the way we have said, we had 2 hydrogen atoms. Then we multiply by, and each hydrogen atom has an atomic mass of 1. So that is 1 times 2 will give us 2 plus 32 plus 4 times 16, which will now give us 98 grams, or just 98. That is that. Then the answer will be now, we'll now get 1.23 divided by 98, which will give us 0.0126 mole. Just simple as eating chapati. Let's see another one is now here we want to now get the mass. Find the mass of 0.2 moles of calcium carbonate. So first of all, ensure you know how to write the compound of calcium carbonate. So calcium is written like that. Then a carbonate, you know, calcium has a valency of 2 positive. Then the carbonate, this is capital O, which is written like that, and it is a radical, does that. So when they swap, the valencies 2 will be, the ratio will be 1:2. Then you will be able to get something written as this. So that is how we write calcium carbonate. So you should be able to add. If you add, that is 40 plus 12 plus 48, because 16 times 3 is 48. Should be able to know that. And how do we get mass? We said moles is equals to mass over molar mass. So when we cross multiply, we'll be able to get what we call mass of the substance in grams. So the mass is given by, that is molar mass times the number of moles. I hope we are together. So the molar mass will be able to calculate. You can see the molar mass, that is the relative atomic mass, or the relative molecular mass, or the relative, or the molar mass. We should just refer it to the molar mass of that compound. That is 40 plus 12 plus 48, which now gives us 100. Then we have said now the mass is given by moles, that is the number of moles times the molar mass, which is given by 0.2, which was the moles of the calcium carbonate, times 100, which now gives you 20 grams. As simple as that. Very magnetic. Let's see the next one. Now let's talk about the molarity. Molarity, more or less the same as concentration. So you should know what you should know. You should be able to know its SI unit. So it's just like concentration, just the way I've said. It can be in grams per liter. It can be in moles per liter. It can be in moles per dm cubed. It can also be written as capital M. Capital M, that is now the molarity of that substance. The molarity exists in solution form. So how? We have several. We have like two formulas for calculating molarity, which we are going to discuss. One, molarity is calculated as moles of solute. Moles of solute over liter of the solution, which I've simplified here. Instead of, if you think this one can confuse you, can use this one. Molarity is moles times 1,000. The reason why we are multiplying by 1,000, we are converting the volume that we are given into liter. So I rather advise you maybe to use the last one for you not to get confused. I want to get that point very well. So molarity is given by moles times 1,000 over the volume of the solution. The reason why we are multiplying by 1,000 is just to convert the volume of the solution into what? Into liter, because you can check here, we said it is number of the moles of the solute over the liter of the solution. So the solution must be in a liter, and 1 liter is equivalent to 1,000 cubic centimeters. Very magnetic. So from here also, we can also get another formula for calculating moles. If also you do subscript, and if also you do the cross multiplication and make moles the subject of the formula, you will be able to get that moles is given by molarity times volume over 1,000. We'll also discuss that. So what I want you to understand, as from where we have reached, we have gotten we have gotten two formulae for calculating moles. One, we have said moles, it can be calculated as the mass over the molar mass. We have also said that the moles also can be calculated as molarity times volume of the solution over 1,000 cubic centimeters. Understand that. So when a question is given, you eliminate the formulae using the statement or what you've been given. If you've been given mass in grams of that substance, maybe of sodium hydroxide, then you should be able to calculate. You can use the first formula that we have discussed, that is molar mass and the mass, which is now the mass over the molar mass. Mass over the molar mass, you can calculate. But if you are now being given the molarity of sodium hydroxide, and also you have been given its solution, the volume of its solution, then you can be able to get its mole. There you say you multiply molarity times that volume that you've been given over 1,000. Inshallah, I've gotten that. Let's see this. Worked examples. So we have, for instance, we have calculate the molarity of a solution containing 4.0 grams of sodium hydroxide dissolved in 500 cubic centimeters of solution. So we have the volume of the solution. We have the mass, and we want the molarity. Get that clear? And we have said molarity is gotten by the moles of the solute over the solution in liter. Or rather, we can say that is moles times the volume of the solution, sorry, times 1,000 over the volume of the solution. I hope we are together there. So what do we, when you are asked to calculate molarity, first of all, write the formula calculating molarity. The first one we have talked about, molarity is calculated as the moles times 1,000 over the volume of the solution. So we have the volume of the solution, and at the back of our mind, we know the 1,000, which will convert this one to liter. We also have that. Then we have the gram, but we don't have what? Moles. So from there, can we calculate the moles of the sodium hydroxide? Yes, we can. We said that moles can be calculated as, that is the mass over molar mass. Mass we have, the molar mass of sodium hydroxide is 40. If you add the atomic masses of elements making the compound of sodium hydroxide, you'll be able to get 40. Like that. So the molar mass of sodium hydroxide is 40. That is 23 plus 16 plus 1. So 23 is for sodium, 16 is for oxygen, and 1 is for hydrogen, because sodium hydroxide is written as this. So that is how we write sodium hydroxide. Then from there, we have the mass. So can we now get the moles of sodium hydroxide? Yes. How? It is mass divided by molar mass, which is 4.0 divided by 40, which will be able to give us that. That is moles is given by mass over molar mass. So that is 4.0 or 40, which will give us 0.1 moles of sodium hydroxide. So we have now the moles. Are you seeing that? We have the moles. Now we can now get the molarity. So it is this moles, we multiply by 1,000, then we divide by volume, just like that. So we said that molarity is just moles times 1,000 over the volume of the solution, all the volume used. If still the we'll be able to understand. So this, I want you to understand this concept and put this formula in your brain. Store them somewhere permanently, because they are going to make your work easier when we'll now be doing calculations involving titration. So make sure you master these formulas. They will help you in calculating problems in titration, of which from our next video, we'll be able to do some titration questions here. So we'll have 0.1. We'll have 0.1 times 1,000 over 500. So we'll be able to get 0.2 m, or we can say it is 0.2 moles per dm cubed, or 0.2 mole per liter. Because sometimes you can be told to leave your answer in moles per liter. This is just the same as moles per dm cubed. Let's proceed on. It is getting nice. We are making it simpler. We have another example here. 5.3 grams of anhydrous sodium carbonate dissolved in 50 cubic centimeters. So now we calculate the molarity. So first of all, calculate the moles. Anhydrous means it has no water for crystallization. So first of all, ensure that you know how to write sodium carbonate. So sodium has a valency of 1, carbonate has a valency of 2. When you swap, the 2 will go to sodium and 1 will go to carbonate. Sawa, that is very good. So from there, you can see now we have 2 sodium atoms. That is now 2 times 23, which will give you 46, plus 12 for carbon, plus 48, which will be 16 times 3, then will give us 106. So from there, we have now the molar mass. Now, what can we do? We calculate the moles. Why? Because to get the molarity, we said that molarity is now moles times the 1,000 divided by the volume of the solution. So now get the moles of the sodium carbonate. It will be, and moles, at first we said moles is given by the mass over molar mass, which is in our case, the mass is 5.3. Then we divide by the molar mass, which is 106. Just the way you can see here. We have divided that and it is giving us 0.05 moles. Then from there, let's now get the molarity. Now it will be moles that we have gotten times 1,000 over 50. The volume used is 50 cubic centimeters. So you can see how simple this thing is. Then we'll be able to get 1.0 M, capital M, stand for molarity. Let's proceed. The last one, this one we have done. No, we have not done this, sorry. We have 5.3 grams of hydrated. Hydrated means there is water for crystallization. So we have hydrated sodium carbonate, like hydrate. We have 10 moles of water for crystallization. So sodium carbonate. So sodium carbonate hydrate, decahydrate. Deca stands for 10. Tri stand for 3. Tetra, 4. Penta, 5. Like that. Then we have sodium carbonate, here 2, CO3. Then we have dot 10 hydrated water of crystallization, like that. So you should be able to get that. We have sodium. Sodium is always 23. Carbon 12. This one 16 times that will be 48. Then you add water is hydrogen is 1 times 2 is 2 plus 16 is 18. Then you multiply by 10. Like that. Let's see. So we have that. We have 23 times 2 because we have 2 sodium atoms plus 12 for carbon plus 16 times 3 for oxygen. Then we'll be able to add 20 plus 1 times 1, I mean, because we have 2 times 10 times 1. And also we get 10 times 16 will be able to give us 286. So from there now gets the moles of that salt, of that one. It will be 5.3 divided by 286, and the answer will be 0.018 5 moles. From there, we can now be able to get the molarity, which will be the moles gotten. You multiply 1,000, then you divide by the volume, which is 50. That one will be able to give you 0.37 m, or 0.3 moles per liter, 0.37 moles per liter, 0.37 mole per dm cubed is the same thing. Very good. The question to calculate the mass of this one. We have been told us to calculate the mass. And now, if a question is given, identify what you have been given. For example, here, we have been given the volume. And also, we have calculated the mass of 25 cubic centimeters of 0.2 m of sodium hydroxide solution. You see that? Yes, now come, we have been given the volume, we have been given 0.2 m. M, we said, stand for molarity. So we have the molarity of sodium hydroxide. So what should we calculate? And we know that mass, we said mass is equals to moles times the molar mass. So to mean we have to calculate moles here. And moles, we said if you have been given the volume and the molarity, you can be able to calculate that by doing what? By saying that moles is given by molarity times the volume of the solution over 1,000. Just the way we have said, moles is given by the molarity times the volume of the solution over 1,000. The reason why we are using this 1,000, we are converting the volume that we were given into liter. Then we'll be able to get that. We know the mole is the molarity is 0.2 times the volume, which was 25. Then we divide by 1,000 will give us 0.05 moles of sodium hydroxide. So from there, we can now calculate the mass. Mass is given by molar mass times moles. So from here, we can get the molar mass of sodium hydroxide. Sodium hydroxide is always 40. Sodium hydroxide. So 23, just 23 for sodium plus 16 for oxygen plus 1 for hydrogen, which will give you 40. Now you multiply 0.05 times 40, which will be able to get, you will be able to get your answer as 0.2 grams of sodium hydroxide. Are you seeing how simple this thing are? So follow, I'll be able to give you the very best to ensure that you understand this sweet topic. Question 3, calculate the volume required. 1, 0.2 moles of sodium hydroxide solution to form that one. So here we have been told to calculate the volume required, that when you dissolve these 1 moles will form a concentration of 0.8 moles of that solution. And from our formula, we said we have been given molarity, we have been given moles. So we need now the volume. Simple, just come to the formula, you write that molarity is given by the number of moles times 1,000 over 1,000, over volume of the solution. So from here, this is what we want. So if this is what we want, we have the moles, the molarity, I mean, which is 0.8, should give us the number of moles we have been given 0.25 times 1,000 then we divide by the number of volume, the volume of the solution that we don't know. So therefore, we can cross multiply. If we cross multiply, the volume itself will be 0.25 times 1,000 over 0.8. Just like that, then you get your answer. So let's see. Let's see how it is done. Guess the volume. The volume is given by moles times 1,000 over molarity. Just the way we made the volume the subject of the formula. Then you can get that it is 0.25 times 1,000 over 0.8 will be able to give you 312.5 cubic centimeters. So we have gotten the volume. So what the important thing here is to master this formula. Master this formulae. They will really help you to calculate any problem that you might be asked to calculate. And from there, you will be able to make these moles, the topic moles, your best subject. It is the easiest. And it will give you marks in Form 3. It will give you marks at even KCSE level because we have the titration paper 3, which involves calculations of moles, molarity, volume, mass, all these things, calculate the water of crystallization, the moles of the water of crystallization. Will be able to demystify this and you will be able to understand, because in my next video, I'll be able to now bring the sample of questions in the paper 3 and how they are calculated and how the titration table is filled. So work with me. I'm here to ensure that everything is taken care of. Now here, do you see what is coming on? We added 100 cubic centimeters was added to the sodium hydroxide solution above. We know that we have the volume, we have the moles, and also we have the molarity. So now you calculate the concentration of the solution. Now this solution, concentration of that solution. That one, you will use this formula, that is the concentration of the first solution times the volume of the first volume, the second concentration times the second volume, where all this C1 is the molarity or the concentration before diluting or adding this more water. Or, sorry, yes, before adding this water. Then the next one, molarity of the concentration after diluting, after adding this. Then volume before diluting or adding water, B2, volume of water after dilution. Then it is just simple. We have V1, the molarity first, is this one, concentration. Then times the first volume, which we got here, should give us to the second volume that we don't know. Then what I want you to understand, you know, when you add, maybe at first it was, at first the volume of the concentration was 312 and it was reaching here. Then if we add another 100, want it to get that if we add another 100, maybe it will reach there. So from here to here is 100. And from here to here is 312.5. So now from here, the volume of all the content, the volume of the content will be now this volume plus this volume, which is will be our volume 2. So it will be this plus that, and we make just the subject of the formula, which will be this one. All this you divide by this times that, shown here. You will be able to get the answer. After multiplying that, you'll be able to divide and get the correct answer. Another issue in calculating molarity. So we have talked one formula. We have talked about the one formula of calculating molarity, which we said it is moles times 1000 over the volume of the solution. Now we are getting another one. Sorry. We are getting another one. That is molarity also can also be gotten as mass per liter, which is grams per liter. And this will use this. This one is always tested in titration questions involving titration. So I want you to understand that molarity, you put this in your mind, that molarity is also gotten as mass per liter over the molar mass. Now let's check this example. Worked example. Solution L contains 20 grams per liter of sodium hydroxide. Calculate the number of moles of sodium hydroxide are contained in 25 cubic centimeters. So we calculate the number of moles. So first of all, you should be able to calculate the number of molarity. You should be able to calculate molarity. Here we have said the molarity, because here you don't see the moles. Even if somebody can think that, see, I've been given sodium hydroxide. See, I can also use this to calculate. Know that you have not been given the mass of the sodium hydroxide, so you cannot use. You cannot calculate its moles, the number of moles direct, where we said number of moles in our first class, or in our previous presentation. We have said that moles is gotten by mass over molar mass. So here we can get the molar mass of sodium hydroxide, but we don't know the moles. We don't know the mass. I mean, this is not the mass. This is a mass in 1000 cubic centimeters is 1 liter. So what you do first, calculate the molarity. If you have been given a concentration in grams per liter, know that you can calculate the molarity of that solution by using the formula that we said. It is mass per liter over the molar mass. So we have the mass per liter, which is 20. You divide by the volume, not the volume, but the molar mass of sodium hydroxide, which is always 40. So it is 20 divided by 40. That will be able to give you this one. So you have the molarity. From there, you can be able to get now, because calculate the number of moles. You can now get the moles by saying moles. We said moles can be calculated as, you have the molarity, you have the volume. Can't you now to calculate the moles? You can, by saying that moles is given by molarity times the volume over 1000. So we have this one, that is, you will only multiply this 0.5 over 1000 multiplied by 25. Then you will be able to get that. So that is that. You will be able to get the answer. So that marks the end of our presentation for today. You remember to subscribe, hit the notification bell so that you'll be notified when we upload a new video. Attention to all students. Do you struggle with understanding the concepts of the chemistry? Do you need a tutor who can guide you through the subject and make it fun and engaging? Look no further. I am Teacher Stephen, an experienced chemistry tutor offering online lessons for students of all levels. Wherever you need, whether you need help with the basics or advanced topics, I am here to help with my personalized approach and easy to understand explanations. You'll be acing your chemistry exams in no time. So why wait? Contact me now to schedule your first session and start your journey towards the chemistry success. Thank you very much and be blessed.